because I could be able to do you regarding another topic, but still chemistry. I love chemistry. Okay, walang katapusang chemistry. Akala nyo ha, walang katapusang politics, but walang katapusang chemistry mga ganun. Okay? Wow! I'm connected na ba? Chart. Okay. So, it's gonna be like this. Okay na? Okay? Okay na siya. Okay, let's go to the most basic chemical bonding in which we encounter this most of the time, especially when we make our coffee, something like that, especially if we're very, very thirsty and we need to drink water like that, and we need to drink too much water so that we can have a good perspiration process. Perspiration meaning the removal of sweat from our body, and then also taking water into their body. It's gonna be respiration, perspiration, something like that. Okay? Okay, it's gonna respiration, perspiration. It's gonna be like that. So actually, it is cellular respiration. In the process of cellular respiration, we need really water intake because we need to have oxygen molecule inside our body. Okay, as usual for for giving energy for us, because again normally carbohydrates composed of mainly oxygen atoms also. Then we need water. Okay, like that. So because water is very polar, okay, something like that. Okay, now we need to have hydrogen bonding. Okay, so this is not difficult because by itself alone you can tell it's gonna be hydrogen doing the chemical bond. Something like so. Hydrogen bonding. Okay, nakakaloka. Okay. So here mga palangga, banding. What do you mean by banding? So let's go back first with the basic terminology by using Webster Dictionary. When you mean of banding, that is basically uniting, combining, okay, like that. It's gonna be a union. It's gonna be adding of something to make it in one entity. Wow, entity. To make it in one group, something like that. For example, there are a lot of groups that make it another one group as one unified group. Wow, di ba? One unified group composed of small small groups, something like that. Or so we can equate that to atoms, molecules, particles, something like that, or ions. Okay, ganon. Okay guys, so hydrogen, so basically this is hydrogen is an element. Mm. Okay, hydrogen H2, ganon, like that, and H negative. Okay, wala sa pero may ganon. Yes, and also this one. Okay, hydrogen can exist in four, something like that. Okay, because we don't have trihydrogen. Okay, hydrogen can exist in multiple characteristics and behaviors. First is a hydrogen alone, like that. Okay, hydrogen alone meaning an atom, something like that. And number two, as a molecule, H2 diatomic molecule. Okay, H2 can exist also as an H positive, which is totally charged when it will be reacted to water in aqueous solution. So it will be ionized, something like that. Okay, so this H positive also. Okay, proton. Okay, the plus here is the proton. Okay, like that. H negative also can exist. For example, hydride. Okay, hydride H negative, and sometimes also can exist also as a hydrate. Okay, so for example, guys, I will relate this This is hydrate because it's negative one. So when can we say that this will become a hydrate? Okay, for example, mga palangga ng hitag, we have iodate, right? Iodate, IO3 negative 1, right? And then iodide, IO2 negative 1. Okay? So, How can we say if it is a hydrate? Okay? How can you say that it is a hydrate now? Okay? How can you do? Just like a silicate, phosphate, okay, sulfate. So basically of course the charge is negative. Okay? Like that. But you will never say silicide. But there is phosphide. Okay? Get what? And we have also hydride. So we have also hydrate. So what is the formula of hydrate? Basically, if you follow this rule, it's gonna be HO3 negative, right? If you follow this rule, but this gonna be the case, not the case. There's no such like this. Okay. So in here, there's no such separate polyatomic anion of a hydrate. Okay, if you try to follow the rule, hydrate, bromate, iodate, like that, silicate, what else? A lot of ATA, sulfate, phosphate, it will never follow on that rule. So hydrate is very, very special. Okay, for example, you have a gypsum. Gypsum meaning really it's being combined to the cement product, right? So it's going to be calcium, sulfate with water. Times, let's say for example, it's gonna times 2 moles of water. Okay. So if you say calcium sulfate times 2 moles of water, so your calcium sulfate here is being hydrated. Meaning you add water and it will become, for example, only for the purpose of discussion because I cannot remember exactly the formula of gypsum, but I am sure that it's calcium sulfate hydrated with water. Very, very sure. But the number of moles, I cannot tell exactly, maybe 2 moles of water, 4 moles of water, but I am sure calcium phosphate, calcium sulfate hydrated. So with H2O. So this is gonna case of the hydrated here. Okay? Hydrated meaning we add water to a certain salt. Okay? Because calcium sulfate is a salt. So for example, sodium phosphate, if you add water, so hydrated, sodium phosphate, hydrated, calcium phosphate, which is your gypsum, something like that. Hydrated, there's a lot of hydrated, for example, potassium sulfate hydrated, potassium sulfate. Your idea will be salts usually, okay, something like that. So this hydrate, chuba chucho is not the same with this polyatomic sulfate, bromate, manganate, oxalate, dichromate, permanganate, ganon. Phosphate. It's not the same with the polyatomic ion. Instead, this will be an additive to a salt. That's why it will become hydrated. Okay? You cannot separate that because if you separate the water from salt, it will just become water. Okay? But when you add hydrated calcium sulfate, ganon, hydrated sodium phosphate, that's why you times 2 moles of water times 4 moles of water. The moles here would represent the stoichiometric relationship of the number of moles ratio between the water molecule and all the sulfate. And then there will be a ratio, stoichiometric, and then that will be the hydrate chuba chuba. Now for the hydride, you can set that as H negative 1. Okay? Like that. So don't be confused with the hydrate with the other chuba chuba here. Hydrated, meaning the removal of water from your body. Okay. Hydrated, meaning there's a lot of water added to your body. Okay, so the K term here is water. Okay, like that. Get the point mga palaga, but not as a separate polyatomic anion, the same as phosphate, sulfate, carbonate, silicate, what else? Phosphate, bromate, dichromate, chromate, manganate, oxalate, and other chuba chuchu. Okay, like that. Oh my gosh. Diba? So, upat ha? Hydrogen as a monoatomic ion. Okay. Monoatomic, diatomic, hydride, and H plus. Okay. The charged hydrogen ion in Arrhenius theory. Okay. Di ba Arrhenius theory will yield hydrogen ion plus 1 when the acid will be introduced with water, something like that. Okay, so for example, hydrochloric acid plus water, it will become H plus, plus already. negative. Ganon. So it's gonna be more on ion like chuba-chuchu. Okay? Like that. Diba? Kaya kasi negative man siya. Okay. Muna siya. Now siya rule, mga palangga umitan. Di ta magpataka because there's a lot of chemical formula involving hydrogen. For example, hydrocarbons. These are reactions involving carbon atom and hydrogen chain explosively. Now, this is not a hydrogen bonding. Okay? Again, all hydrocarbon is not a hydrogen bonding, chemical bonding. That is covalent bonding. Okay? Now, technically and specifically without proving in theory, these are all non-polar. Okay? You get the point? These are all non-polar, except if we will examine as London dispersion forces or the weak electromolecular forces. I hate this intermolecular forces because I'm struggling this when I was in second year college or first year college. I cannot understand very well, really. Just now. Chop! Grabe, just now. Okay? Nakakalawa to. Okay, ganun siyang matalaga. So, again, hydrocarbons are hydrogen bonding. Okay, and also alcohol is not really a hydrogen bonding. Why? Because it involves carbon, oxygen, and hydrogen. What's really hydrogen bonding, mga palangga? Okay. Hydrogen bonding is chemically combined with nitrogen, oxygen, and phosphorus only exclusive. When hydrogen will be added to nitrogen, oxygen, and phosphorus. So if you add this into carbon, it is not a hydrogen bonding. That's only a bitik. Kailangan siya hydrogen. Di konra ang mga examiners or mga during examination because it will be there in the multiple choice. Okay, which of the following involves hydrogen bonding? A. Methanol. Ano ba yun? A. Methanol. B. Gasoline. C. For example, ascorbic acid. Okay? D. Ammonia. E. None of the above. So the answer will be ammonia because hydrogen plus nitrogen. Because hydrogen reacted with nitrogen, oxygen, and phosphorus. Okay? Other than this, it will never call a hydrogen bonding anymore. So there's a rule. Okay? And you have to remember that because this will come out sometimes in theory questions in the board examination. Get the point? Diba? So, mga siya hydrogen bonding. Now, how can we explain this? For example, I need to bring the water and add with another water, a glass of water plus a pitcher of water. So I have H2O. So H2O, ganun. H2O plus H2O. Okay, the product will be 2 moles of H2O. Again, no need to explain by math. Okay, 1 mole of water plus 1 mole of water equals 2 moles of water. Simply addition. Now, I will explain to you the hydrogen bonding. Okay, now make a Lewis dot structure for H2O and make also a Lewis dot structure of H2O. Now, knowing that water is highly polar, okay, means to say polarizable, meaning it will create a dipole moment. It will create a dipole-dipole reaction because of the electrons will be distorted. Okay? Distorted talaga. Okay? Nakakaloka. Okay, so H2, ganun siya guys mga palangga ha. Okay. So oxygen, ganun chuchu, ganun. So mura siya kuan guys. 45 degrees or it's gonna be 35 siya, 180 degrees. Okay? Inana siya. Okay? Ang imong water. Okay. So one electron of hydrogen will combine to the 1 electron of oxygen here. Hydrogen like this. Okay? Hydrogen guys, even though this is a gas, this is also electropositive because the charge is positive 1. Okay? That's why electropositive. So very, very ready also to share this electron to other nonmetals. So nonmetals are electronegative. Now oxygen has a negative 2 charge, obviously electronegative. Okay, something like that. Okay. So this oxygen, he is very, very thirst to receive the electrons from hydrogen. So it will become more electronegative. O, something, ganon, like 4 unpaired electrons here. Ganon. So 4 unpaired electrons and 2 electrons of oxygen will be shared. Ganon, to hydrogen. So mo rin siya. Oh, here, one dipole moment. Here, one dipole moment. Okay? So, like that. So, one dipole moment will be cancelled because they are in opposite direction. Cancel, cancel, like that. That's why it will become polar. Okay? Get the point, mga palangga? So, that's why it's also called dipole-dipole bonding or hydrogen bonding. Okay? Correct me if I'm wrong, ha? Mong gitawag siya dipole because of di. Why di? Because the one electron in hydrogen connect to the other electron of oxygen. So 1, 2. So di. And then that is, we term pole in chemical reaction. If we try to have a dot, that is also pole. P-O-L-E. Okay? The noun is pole. Now, it will become adjective. It will become polar. Okay, the root term is pole. And it will become adjective, it will become polar. Okay, that's why water high polarity. Because there are two dipoles. Okay, from the other side and the other side. Okay? Get the point? Ganon. So this is hydrogen bonding. But there's another water here. Can you plus? Okay. Now, this will become partially negative yung oxygen. Okay, partially negative. Kaya na-bend man siya. So if ever there is bending moment galore, it will become partially negative. Okay, ang hydrogen. Ni-bend man siya tungkol sa hydrogen na padulong sa ubos. Now, we have another water here. Okay, something like this. Okay, there's another water. Talagat ganon. Talagat ganon. Talagat ganon. Okay, now, the partially negative oxygen will react to the hydrogen here on the other molecule of water in which we add. Because I have two water here. Okay, 1 mole of water plus 1 mole of water. Okay? So this H will become partially positive and the other oxygen is partially negative and they will combine with each other. Ganon. So the distance between the oxygen and the hydrogen is what we call as a dipole distance. Ganon. This is a dipole distance establishing now a dipole moment. Ganon. Dipole moment. Like that. They're now happy with each other because they are combined. The opposite partially charged negative oxygen and the partially positive hydrogen, and it will have a dipole distance or dipole moment. Now, here, where your hydrogen bonding takes place. Hydrogen bonding. Okay. The hydrogen bonding mga palaga, it's not the H to H. Okay? It's the H when another, okay, gases, for example, nitrogen, oxygen, phosphorus, or non-metals. Okay? It's not H to H. That is not hydrogen bonding also. This is also a trick. Because what's in your mind, if there is hydrogen, automatic hydrogen bonding, it is not. So there's a rule. It is only hydrogen bonding if it will react to nitrogen, oxygen, and phosphorus, but never carbon and other metals. And never also by itself, hydrogen plus hydrogen, but that's not also hydrogen bonding. Imagine, okay, hydrogen plus hydrogen plus. It's not hydrogen bonding because they are both plus, they will never react. Okay, they are not neutralized with each other. Okay, because there will be no electrostatic forces and intermolecular forces if the charges are not opposite with each other. Okay? Ganon. Get the point? Okay, here is the hydrogen bonding. The partially negative oxygen will be added to the partially positive hydrogen. Ganon. Now, where is the intermolecular forces so that we can understand? How can we define intermolecular forces? Okay. In chemistry, especially if you are taking masters in polymer chemistry, some polymer, okay, polymer chemistry, or shall we say sugars, polysaccharides, mga ganun. So you should know this technique, okay? Intermolecular forces. Okay, the other name also intermolecular reactions or interactions. Reactions and interactions are equal in meaning, but the interaction is between two molecules, but the reaction not necessarily. You get the point? Reaction is a term general, whether it is outside, inside, from the molecules and atoms. But the enter is another story. It's in between the two, not inside of that atom or component. There's a difference. When can we say interaction and reaction in dictionary? You get the point? You get the point? Because when you react, not necessarily the other will react to you back. So that is reaction. But interaction, if you react to him, the other also will bounce back to react. So that's the difference. The usage in the grammar, how can we use interaction and reaction? For example, I am speaking to here. If you interact with me, you react with me, I react with you, we reacted with each other. That is interaction. Okay. Now, if I will only react and the other will not react, so that is only reaction. Okay. So the same story here also. Yeah. Intermolecular interaction and intermolecular reaction. So we don't use the reaction, instead use the intermolecular interaction because this is between two molecules with each other, not only in the inside of the atom. So be careful with the chemistry grammar, not only the English grammar. You get the point? Oh, ganon. If we have the math grammar, we have also the chemistry grammar or science grammar, we have also basically the English grammar. Okay, something like that. So we use intermolecular interaction, not reaction. Okay. So if I will recall the three laws of Isaac Newton in physics. So there's three laws as far as we could remember in our technology. First, the law of interaction. Second, first, the law of inertia. Second is the law of acceleration. And third is a law of interaction, not reaction. Okay? Because in every action, there must be equal and opposite reaction. Okay? But that is the law of interaction. Kaya di ko lang kung equal and opposite. So, both sides have reaction, right? So that's interaction. Ano naman? The same as interaction. You get the point? It depends how you phrase the sentence also. So that's why that is the third law of interaction, not the third law of reaction. You get the point? There's a difference, guys. Okay? Like that. Okay? So that's very, very clear. Intermolecular forces, intermolecular interaction, and intermolecular bond. Because when we speak of bond, we are considering the other atom and the other molecule, they connect with each other to form a poles, P-O-L-E-S. That's why dipole, ganon, because two. You got the point? So, ganon pa. We should be highly technical, something like that, okay? You got the point? Now, the intermolecular forces, how can we define now? Intermolecular forces. So the intermolecular forces or the intermolecular interaction is really, okay, the interaction between two molecules. Could either be the same molecules or different molecules. Like that. So basically, I am talking with molecule, so meaning the same molecular compound, not ionic compound. Meaning reaction only with non-metals and then metals, such as hydrogen gas plus oxygen gas, water. Meaning to say, both are non-metals, so molecular. So for example, if the questions in the theory, in the board examination in the future, we say, what are the products if you react metals and non-metals? Okay, you will never say molecule. You get the point? For example, I will react sodium chloride plus water, and you will obtain hydrochloric acid and sodium hydroxide. Neutralization reaction and hydrolysis reaction, or something like that. Now, take note, okay? You will never say like that, okay? Got the point? O muna siya mga palangga. Take note kita ha. So muna siya hydrogen bonding, intermolecular forces. Here. Okay? Like that. So, there are two molecules, one the other one water, the other one is water. Okay? Like that. Got the point mga palangga ha. Ang time to ay, katugo na ba ito? Charot! Charot lang. Diba? Alam. Mali ang pagkila. Okay? Muna siya. So, intermolecular forces. Okay? The same as internet. Internet, you can connect anywhere because that is between 2, 3, 4 parties connectively. But if you say intra, it's not the same. It's only within the room, within the school, that's intranet. The same also we have intramolecular forces. So the prefix enter and intra in English, there's a difference. And we attach the net. So that's why internet, intranet. Here we attach only the molecular because these are all molecular compounds. That's why intramolecular. Intermolecular. Now I will explain to you the intramolecular. Intramolecular forces are forces or interactions within one molecule only, not in between the two molecules. Within, okay? For example, if I have if I have methane, we have intramolecular forces there between carbon and hydrogen. But when the methane will be reacted to, let's say, ascorbic acid, it's no longer intramolecular forces there. It's intermolecular forces or intermolecular interactions. I just try to emphasize what's the difference between intramolecular and intermolecular. Okay? So, you get the point. Muna siya. Okay. Okay? Get the point. So, sana may ano rin, no? Intranational because there's international. Right? But, wala man siya gina-practice. Pero kung mo yung pugson, pwede siya because the intra means within. Okay? Within that countries. I mean, intra-national. International in a lot of countries nearby, situated 2, 3, 4 like that. That's why international. Diba? So, inter and intra, prefixes na siya sa English. Okay. Get the point? Ganon. So, you can now define what is an intermolecular forces, hydrogen bonding. So, any questions so far? Mga panangkaungitan. Charot! Now, before we end this video, so, dagan pa man siya guys, pwede ka mag-add of, ang sikreto ano pwede ka mag-add of mga, for example, polar compounds, but not hydrogen bonding anymore. I'm emphasizing the intermolecular forces. For example, I will add, not hydrogen bonding, if you add carbon dioxide to another carbon dioxide, like this, okay, carbon monoxide to another carbon monoxide, like that, okay, one shot, okay, one shot may tabo. Okay, now before we end, I must emphasize also ang difference sa atom, sa ion, sa molecule, sa particle. Okay, so atom first. Atom is the tiniest and smallest particle that made up of an element. So for example, if I have chlorine, one chlorine of atom has an atomic weight of 35.5. So it's referring only to one atom. If it is a compound, there are two atoms na siya. Okay? Get the point? So, I have aluminum. Okay. If I will just put aluminum mga palangga, this is an atom. Okay? Aluminum only without charge. So, meaning to say, if we say an atom, that is neutral. Naturally neutral, meaning no charge. So, neutral aluminum. Since we know that already, that's why we just say aluminum only. But with that neutral, because the charge is zero. Okay. So if the charge is zero, meaning to say that is the neutron. Neutron is equal to zero. Neutron. Okay, ganon. Now, so that is an atom. Now, what is an ion? Aluminum atom, aluminum ion na ta. So if we say aluminum atom, there will be a charge already. Sa taas, whether positive 3 or let's say positive 2. Sa 2 charges na may aluminum o usa ba? Let's say usa lang siya. Okay? Positive 3. The aluminum positive 3 is already an ion because there's a charge. Okay? Meaning to say, an ion usually a result or a product when you react that aluminum into a certain solvent or liquid in aqueous solution or whatever to yield a charge, positive 3, which is the cation. Okay? So basically, the cation is a positively charged ion. Okay? Positively charged ion. Okay. Get the point? Since positive 3 can also interpreted as electrons when it will become lost. Because I told you earlier, all elements, no, metals, not elements, okay? All metals are electropositive. When they give these electrons to the hungry people, such as the non-metals, it will become, okay, now, the called positive proton. Okay? Proton. Okay? Positive 3 proton. Now, if this will become positive proton, positive 3 charge, you can say basically that this is also a particle. Okay? Because what we mean of particle is basically the proton, the neutron, and the electron. Get the point? Oh, ganun siya. Get the point? So, ayun siya buting charge because this is an atom. Okay? You get the point. Okay. Now, a molecule. Molecule na sa siya. For example, aluminum, let's say, hematite. I memorize this when I was in first year college. Hematite is Al2O3. And we have also magnetite. Okay. AlO2, aluminum oxide, right? No, this is not hematite. I think so. This is alumina only. Sorry, alumina. 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 Okay? Because hematite, based on my brain cells recall just now, flashback, it's Fe2O3. Hematite and magnetite is Fe3O4. And this Al2O3 is alumina. Okay? You get the point? Because silica is SiO2, right? Because silicate, when you put a charge, something like that, but there's no charge at the silica. That's the differentiation between how to say it is a silica or a silicate. It's the charge matters. That is only silica. The same as here, alumina. Because Al2O3 has no charge. This is a neutral compound. Okay. When it's become a neutral compound, it will now become one molecule. One molecule of aluminum oxide. Sorry. Nawa ko. Aluminum oxide. Sa sobrang dagang kaya sa brain cells. Okay, muna siya. One molecule of alumina. So, molecule ang tawag ani. Because banded naman ang two atoms sa aluminum ug sa oxygen. So basically, we'll say molecule definition is a combination or is a union or uniting two atoms or more made up so they can produce a compound. Okay, that's the definition of molecule. Ako lang na definition because I tried not to be bookish. Okay, something like that. But the definition there in the books is really like this. Two or more atoms are joined together in a compound, something like that. But I might try to revise something. It's just the same. Okay, so one atom of aluminum plus one atom of oxygen. That's why aluminum oxide. So okay, generally. Okay. Subscript, alas consider subscript. It's another story by a shot. Charot, gabungkad. Charot lang. Okay, ganon. Okay, ganon. Oh, di ba? Any questions so far mga palangga? Wala na siya. Okay. Thank you so much for watching this video. Bye-bye. God bless everybody. I hope you like this and you can comment down below in the comment section and share if you want also to share this video. And then you can also subscribe to my channel if you want, and you can click the notification bell for some news updates with I am Singer, Eternal Voice. Bye-bye. God bless everybody. I'll be coming back for a short while. I'll be discussing the London forces. Okay. Wow. London dispersion. Why London? Sa pa United Kingdom. Charot. Okay. London dispersion forces. Wow, di ba? Ganon. Charot lang. Di ba?